Hey everyone. I hope you're doing amazingly well. Thank you for being back here with us. First of all, I wanted to apologize for not having posted in a while, especially this long form content. Um, I know when I created this channel, it was to share uh, my knowledge. Whether you're following from CreezyCreates, CreezyCreates was put together to share my knowledge with everyone, to share kind of how it is to build and release products, right? And Series Speaks was really for the French-speaking community and created to more of as an advice channel, as a career advice and also technical advice, technical mentoring, right? So uh, I've been a little bit busy and I apologize. So the commitment that I make to you in front of everyone is that I will do everything that I can to post at least one video every Thursday, right? Where we go over technical a technical problem that we solve, right? And these problems are going to be architecture based. They're going to be simple enough for everyone to follow as far as the problem, but we're going to we're going to solve them from an architectural perspective. So we're going to take a problem, uh, look at what the problem is, how we're going to solve it, obviously, how we're going to approach the solution. We're going to look at the different possible solutions, the trade-off of each solution, whether it's in terms of performance, um, or whether it's in terms of scalability, things of that nature. We're going to write architecture documents, right? And in those architecture documents, we will go over the problem. We will go over the possible solution, the possible trade-off that we are going to make, the scope of our solution. Also, the other thing that we are going to do is we are, of course, going to have architecture diagrams, right, explaining the architecture that we chose, why we chose it, the limitation of that architecture, the problem it solves, how it helps us solve this problem better, faster. And also, in that document, of course, we will have diagrams showing the different classes and maybe some sequence diagram, right, for the most important use cases. And the goal of this series, and also after that, after we have that software piece, we're also going to look at issues like scalability, deploying, right, deploying a solution to a server, to whether it's server like IIS, whether it's on the cloud, like on Azure or AWS, we will go through that entire process. We also, for example, see things, concepts like containers, work with technology like Docker and Kafka, right? When they need be. So it's really a way for us to basically um, solve problems, right? From point A to point B, meaning taking a problem, uh, finding the solution, architecting the solution, building the solution, deploying the solution, and scaling the solution, right? That's kind of what this exercise are going to be. And my goal is to do first one a week because it takes time to record, time to do them. And usually I will, fair warning, I might have prepared one or two documents beforehand, right? So that the videos are not too long, right? So that's that. But if there's interest, I will do uh, maybe 2 or 3 a week, right? If interest is shown, but I commit to one a week for now. So, for my French speakers, you should be able to see subtitles. The reason, of course, I speak in English is because more of the world speak English than French, and right, we want to talk to everyone. So for those coming from Series Speaks, you should have subtitles in French. If you don't see the subtitles, please make sure to comment. If you're watching here on YouTube, make sure to comment below so that I activate them, or comment on TikTok where you came from. Okay. Okay. So of course, don't forget to subscribe and like, share, of course. All right. So what are we doing today? So today we are going to solve an interesting problem. And basically, the problem that we are going to solve is simple. So imagine we are going to build a device command service for a smart home. So we have a home and we have smart devices like a front door or door has a lock. We have a smart thermostat. We have a smart panel. So the basic problem sounds simple. Imagine that we have a mobile application that control different devices. Okay, in your home. So one second. Different devices in your home. Okay. Um, so we have smart locks, lights, thermostats, security panel, and potentially many other type of device that are going to come in the future. So from the application, as a user, I should be able to send a command such as lock my front door, turn on my light, right? Or set the thermostat in my home to 72 degrees. But the interesting engineering problem isn't the button on the mobile application, actually, right? As you can imagine, it's everything that is going to happen behind that press, right? That button press. So how are we going to represent those devices? How are we going to model the commands that are being sent? Okay. How do we determine whether a particular device accepts a particular command? How do we prevent the same command from accidentally being processed multiple times? For those that are already advanced, you see where this is going. We're going to talk about things like idempotency keys, fingerprint requests, and things of that nature. So you see where this is going, right? So the other question is that how do we persist these commands that we're sending from the mobile app reliably, right? So these are questions that we need to be able to answer, right? That our system needs to be able to answer. And most importantly, how do we design these systems so that what we are building today doesn't prevent us from evolving the architecture tomorrow, because the needs of the system, the need of the business might change, right? So the architecture needs to be able to evolve with the needs of the business without breaking everything that already exists. So that's the challenge that we are going to walk throughout this series and other episodes, right? So before writing the implementation, I started with the architecture and the domain model. So right now you are seeing my solution, but this is actually I should probably show you uh, first of all the problem statement. Okay, I should probably show you the problem statement. One second. Okay. Okay. I will show you the problem statement. Okay, I went over the problem statement. So I will show you the problem statement. I will show you also my architecture analysis document, right? So you can have an idea of what this look like. But we're going to focus, for the sake of brevity and time, we're going to focus on the uh on the architecture diagram document. Okay. So right now, but I'm going to show you the architecture analysis. Okay. So so that you have an idea of what it looks like. Okay. So let me stop sharing and then I will share another window. Okay. Right. Okay, perfect. So I'll share this window here. So now you should see my browser. So this is my architecture analysis, right? Based on the problem statement that I kind of gave you, right? So usually you will see in an architecture analysis document, you will basically outline the problem, right? What is the problem that you are solving, right? So I'm just going to read, we are building the command service to enable smart home owners to remotely control the smart devices in their homes, right? The service is a collection of reachable cloud APIs working on the server, right? So You state the problem, right? And then you state the scope, right? Like what your solution, what your system, what are the problems that your systems are going to solve, right? In this iteration, right? Let's say in this first version, and what is not going to address, what are the limitations, right? That's what you do in the scope, okay? And then you talk about the architecture choice that you are going to make. In my case, I chose a modular monolith, meaning that we are going to organize our system into modules that can later be broken down into microservices if need be. Okay, that's the architecture path philosophy that I'm going to use. And as far as how the code is going to be organized, the structure, I'm going to use clean architecture, right? So if you need references, you can Google that. There are books about clean architecture, right? So, and I explained why I'm choosing a modular monolith, right? One of the advantages of modular monolith is able to break down our layers already as modules that can later be reused as microservices, right? So, and then we have as I mentioned, we have the main components, right, in our system. And I mentioned we're going to use clean architecture. So we're going to have our API layer, right? That's what external system like a mobile app or web app are going to use to communicate with us, right? And then we're going to have our application layer. That's where our use cases or services are going to be, okay? Then we're going to have our domain layer. This is where the entities, the data related to the application, like data like device commands are going to be defined. And we're going to have the infrastructure layer where we are going to have the actual implementation of things like persistent system. This is where we're actually going to implement how we do, for example, persistent storage and things of that nature. Because at the application layer, the advantage of the architecture is that there's a separation of concern. In the application layer, we define the algorithms, right? But we don't define, for example, let's say we in our code, in our code in the class, storing, we are registering a device. Okay, in this case, we are going to say that we are going to store the device, but not going to specify how we are going to store, like what technology underneath, right? So we're going to use, of course, interfaces in order to do that. So it's in the infrastructure layer that implementation detail is actually taking place, is going to take place. Okay. So um, in this layer, in the API layer, we're going to expose the endpoint, with which the external world communicate with via REST with our device services, right? So this endpoint make use of the device application layer. In the device application, like I mentioned, in this layer, this is where we define and implement the business rules and the logic that support the different use cases, right? For the microservice, the device application layer will make use of the classes that are in the domain layer, right? So in the domain layer, we implement the domain classes that represent the entities that the services deal with. Okay. For example, in this microservices, we can have entities like device, command, etc. So the domain layer does not depend on any other layer, right? It's completely independent. And then we have the infrastructure. So this is, like I mentioned, this is where we implement uh, the infrastructure that support the application layer. Okay. It's important to note that this layer references the device application and device domain layer. So by doing this, we're doing reverse dependency, right? So it enables us to have our application layer completely independent of the infrastructure, so we can test our application layer independently of the infrastructure, okay? Which is going to be very useful for when we write unit tests and things of that nature, okay? So we have a diagram here, right? I can make that a little bit bigger for you. Okay. So you see that you have a client, right? You have a client here, a mobile app or web app. It calls, like I was saying, he's going to make a call to our API where we have our controllers, okay? And then our API is going to call application layer. In the application layer, we have our application services, the business rules, the validation, where we validate the input, and then we execute the business rule, and then we have our repository interfaces, right? Because in our repository interfaces, we describe what data needs to be sourced or what data needs to be retrieved and things like that. But then our application service interact with the domain layer. So this is where we define our entities, right? Our commands and our requests, things of that nature. And then our repository interfaces are going to be implemented in the infrastructure layer, right? This is what you're seeing there, where you're saying that we have the repository implementation, right? That implement the repository interfaces defined in the application layer. Okay. That's why I say this is a reverse dependency. Okay. So that's what it is. Okay. And then usually in an architecture document, you also define why you make why you made the choices that you made. Like why did you choose, for example, why did you choose SQL? Why did you choose C#? You have to justify those choices, right? So me, I chose SQL storage because it's a relational database. And one of the advantages of relational database over non-relational is that there's data consistency and integrity, right? That is enforced by the relationship. So I also define where business rules belong. Some business rules will live in domain classes, and etc. And I define and idempotency. So in idempotency here simply means that if you are doing the same action twice on a record that has the same idempotency key, you should get back the same result, right? So that prevents records from being processed, the same record from being processed several times. Okay. So how do we prevent duplicate idempotency keys? So those are things that we are discussing in this document, right? And then we have the trade-off, right? Simple service versus microservice, the JSON payload versus separate command fields, right? Because we could have had one table, right? For example, in the command table, we could have just have the payload instead of having separate command fields, right? Repository abstraction versus direct AF core use and et cetera, et cetera. So this is just to show you an example of an architecture analysis, right? Basically. And to be honest, I've done this, like you said, the date is 8/02. So I've done this a few days ago. Today we are 8/20, so it's been a little bit, it's been 18 days. So I apologize if I'm a little bit rusty in explaining. So, but yeah, so that was done about 18 days ago. I'm a little bit late on recording and shooting this video. Okay. So that's the architecture analysis. And if you want this, let me know. I will put it in the description for you to get it, right? No gatekeeping here. Okay. So, and also, of course, I'll put the repository when the series is over. I'll put the GitHub repository so that you can check out the code and work with it, right? Okay. So now, one thing that I want to show you is the architecture diagrams, right? Here, as I mentioned, we have quote unquote 4 layers. We have the API layer, if you want to think about it like that. You have the application layer where we have our business rule. You have the domain layer where we have our business entities, right? Then you have the infrastructure layer where we have the implementation of the infrastructure supporting the application, right? Okay. So here you can see our device command service, right, which is a modular monolith. We have the device API project here. We have a REST controller. We have a middleware that is going to handle exception, right? Things like that. We have the application layer, right? And in the application layer, we see that we are defining the different use cases. We have the register device use cases, right? Where we register a device, right? Because before you can send the command, you have to register the device on the network, right, on the system. So we just say the device, we have the submit command use case. This is where you actually send the command. Okay. We have the retrieve command use case. This is when we get a command, a specific command. We have release device command use case. So these are all the use cases that are supported in the application, that are going to be supported in the application layer. And we have our repository interfaces, right? And remember, I said interfaces, not concrete implementation. And those interfaces are actually implemented. The repository interfaces and other interfaces are going to be implemented. A lot of those interfaces are going to be implemented in the infrastructure layer. Again, this is to decouple the application from the infrastructure so that, again, the application layer can be testable independently of all the other layers, right? So that's that. So here we have in the infrastructure, we have our like the implementation of a repository, like the device repository, the command repository, and then we have our entity framework database context, right? And in the domain, you see that we have our entity classes, the device entity class, device command entity, and or enums objects, right? And you have a SQL Server database here. And here you're going to have in the future, right? The commands that we are going to send are going to be read by a gateway service, because you could ask yourself, why don't the device just call the API directly to get the commands, right? It is because those devices usually they have lower power, right? And making those, if they were to make those calls directly, it will take a lot of resources, right? So we have a gateway service, right? And that gateway service is the one that get the command from the pending commands from the SQL Server, and actually send that and communicate that to the physical device via a Z-Wave, Zigbee bridge. Okay, so that's how it actually works, right? So there's no direct communication. The device doesn't directly communicate with our API. Or API get the command, put it in the database, and then there's a gateway service that pull those commands and then send it to the device, right? Okay, via a bridge, via some sort of a hub, and that's the hub that is communicating with the device in the home. So there's a hub in the home. Okay, the hub is the one that is pulling the commands from our database where the commands are pushed, and then that hub sends those commands into the physical device in the home. And when those commands are sent to the physical device, they know what to do. For example, I send a lock front door from the mobile application. That lock front door go to the REST API, go to the application, where we make sure that the lock front door that was sent, the command that was sent for a particular device, the first that the device exists, that is online, right? And that the command that is sent, that the lock front door is actually for a door, right? For an actual door, okay. And then we make sure that that command is not how can I say, wasn't make sure that that command wasn't sent before. Okay, if it was sent, if it was already sent before, we return that command. We don't process it, right? So if it wasn't sent before, we then store that command, right? So when that command is stored, then the gateway service will pull that command is stored with the status pending, right? So the gateway service will pull the commands that have pending status, right? And then dispatch those commands to the device in the home, right? And then the device will basically act based on the commands that they receive. Okay, all right. So that's kind of the component. Now we have our database diagram here, or ER diagram. Right now we have, I mean, it's a simplified version, but we have the device command and the device. So as you can see, it's a one-to-many relationship from a device to the device command. A device can receive multiple commands, but a command can only be issued to one device. Okay. So, and you see that in the device command, we have the ID of the command, we have the device ID, the ID of the device that this command is being sent to. We have the command type, the payload, right? So the information that the command is sending, the status of the command, the dependency key, the dependency key that tell us where the command is coming from. The request fingerprint basically is a fingerprint for that identify. How can I say? Is like its name indicates, it's a fingerprint that tells us which command was sent, which command was sent for which device and for what payload, right? So the independency key and the request fingerprint kind of enable us to know if the command which command it is, right? So we will see that we have the date at which the command was created, the date at which the command was last modified. And then we have the device, right? We have an external device ID. It can be a MAC address or something like that. We have the name of the device type, the data which was created, modified, or deleted. Okay. So that's the ER diagram. And then you have the UML diagram. So here, I'm going to make it just a little bit bigger. Okay. So you see, this is the classes that we have in our domain, right? We have the device command, right? That implements, that inherit from an entity, right? And then we have a device that has, like I say, a device can receive multiple commands, right? So the device has a collection of commands, and then the device has a device type. Okay, and also we've made the device, because the device can be removed from the system, so it's deletable. So we created an interface called iSoft deletable. So it has a deleted date and if you a Boolean value indicating if it was deleted. Okay, so this is the domain layer. Okay, and then we have the comment type, comment status, etc. Okay, so here we have this is let me okay, this is the application layer. Okay, and the reason I'm going through this, let me see. We are about okay. So this is the application layer. Okay, in the application layer, we have our use cases. If you remember, I have to make it very okay. Okay, let me go back to 150. Okay. So we have our application there where we have our different use cases. You see that we have our submit command use case. So this is what happened when when the user sends a command from the mobile device. And you see that in this use case, we have like the execute async function, right? It takes the command and it takes the cancellation token. The cancellation token enables us to roll if there's a mistake or anything like that. We can roll back or suspend the action, right, that we are doing. And you see that the submit command use cases use iDevice repository, right, to manage the information about the device, the device command repository, the iCommand policy observer, the iRequest fingerprint service, the iUnit of work, right, because we're using the repository pattern, right. In the repository pattern, you do several operation, right, like creating, updating, deleting, and all of those make a unit of work, and then you save that unit of work, right? For those of you that know entity framework, that just means save changes. Okay. And then you have iClock. Okay, so basically what you have to remember is that in the application layer, we have our different use cases, right? So yes. So we have our different use cases. We have the submit command use case. We have the get command use case. We basically retrieve a single command, right? By SID. We have the get device commands use case where we get a list of commands, right? That we can query a list of commands, right? And then we have our different interfaces here. So these are the different interfaces for our use cases. So I register device use case, I submit command use case, I get command use case, I get device command use case. So we're going to delve deep in the code for that. And then we also have the repositories, right? iDevice repository, iDevice command repository, right? And this is where we actually get data from our data source. So this is where we define get by ID, get by external ID, etc. And then we have our unit of work, save changes. We have our clock here to be able to get the current time. And then the request fingerprint service in order to be able to create a fingerprint, right? So this is our infrastructure layer, right? This is actually where we have the concrete implementation of the repositories. So we have the device repositories, the device command repository, and they both use a database, an entity framework DB context. In this case, we call it devices DB context, right? Which is basically our unit of work. And we have, for each repository, we have a separate function. For example, the device repository, we have get by ID, get by external ID, exists, etc. So, so this is what we have, okay? I hope this kind of makes sense. I know I've just skimmed through. Again, these will be made available to you. I will put I'll put them. They will be in the repository. The reason I don't share the repository yet is because since we are still building this and it's not over yet, I will share the, if you want the diagrams, put in the comment, one diagram, right? Or one documentation, and I will happily share the link with you guys. Okay. So this is actually what we have. Now, I know this is, again, I'm sorry if it was kind of fast. I'm trying to keep these videos short, but I think I'm going to fail in doing that. But hopefully they are not too boring. Okay. So now the next thing that we are going to do, so since we did a recap we went over what the problem is. Okay. I went over the architecture analysis. We went over the architecture diagram. And we're going to look at the code now. So I'm going to stop sharing and share back again my Visual Studio. Okay. So, right. So this is actually where our architecture, everything that we saw before comes alive, right? So you see that we created a solution folder here called devices. And this is our device module, right? Like I mentioned before, we are doing modular monolith. So if we were to, for example, go to microservices, we could basically just deploy this whole devices as a one unit, right? Because it will be, it will have its own database and things like that. Okay. So, and in here, in this modular monolith, we have our devices.api. Okay. This is our API layer. We have our controllers. Right now, there's nothing. Okay. These are just, how can I say, dummy controllers. We have our device.application. Okay. So you will see device application. As we mentioned, the application layer, this is where we define the business rule, the logic, etc., right? And the use cases. So if you remember, we have different use cases. There's get command use case, get device command use case, register device use case. The one thing that we are missing is the submit device command use case. That we haven't implemented that. So we are going to implement that. Okay. So these are the use cases. You see that they are here. And now we have our validation, right? Okay. But before we look at that, you see that we have a folder here called interfaces. This is where we define all the interfaces that are in the application layer. Okay. So for example, for the use cases, we have the I get command use case. It has a method execute async. It takes the command ID, right? Basically, because we want to get the specific command that has a specific ID. So that's what we're doing here. Okay. Then we have the I get device commands use case, right? Here we get a query, right? We get device commands query. So let's look at that. Let's say, sorry. So we go to queries. So you see that this query, this is the parameters of the query. So you can send a device ID, the page number, the page size. So basically what we're saying here is that we want to get the commands that the device received page by page. Okay. I mean, not necessarily page by page, but it depends on the parameters that we have here. But so here we have the device ID, we have the page number and the page size. So if you send the device ID, you send the page number and you send the page size. That means that give me, for example, the commands that this device received for page one, because the device might have received 10,000 commands, right? You don't want to get all those commands at once. This will for the device that can create performance issues the more commands that you have that the system receive. So we paging, right? So in order to encapsulate that, we have this get device command query. Okay. So this is the query that we use to get the commands that a device receive. And again, that get device commands query can evolve. Right now, you only have the device ID, the page, and the page number and the page size. But you can imagine, for example, I might want to get it by MAC address, or I can, there can be several parameters that you can put in that query object, right? And you can imagine that you can do interesting things, right? But we're going to keep it simple for now, okay? So that's the get device commands query, okay? Okay, I'm sorry, that's the get device commands use case, okay? Uh, right. So use case, and then you have the I submit command use case. This is where, like I mentioned, when you're on the device, when you press the button to send your command, this behind the scene will get executed. So you see that we have this execute async function. It takes a submit device command, and we have our cancellation token, right? And as I mentioned before, the cancellation token is if for some mistake, let's say for some reason the connection gets dropped from the client, okay? The cancellation token will then be invoked, right? And basically we'll check, it will determine that we lost connection with the client, and then it will stop the operation, basically, right? And throw an exception. That's why we use cancellation token. So we don't waste. So in this particular case scenario that I specified, we're not going to waste time trying to complete this process while we no longer have connection with the client, and we can return back the answer to that client. Okay. So we have the submit device command. So let's look at what this class look like. So you see that it takes a device ID. It has the command type. So when you're sending a command, we need to know for which device is sent, for which device this command is for. The type of command it is. Is it the lock front door? Is it a set the thermostat? What is it? And then you have the payload, which are the information that the command has. For example, let's say you're setting the temperature. The payload will have this payload will have the value of the temperature that you want to set your thermostat at, and maybe other parameters, right? And then you have the idempotency key, which is basically it tells us uniquely, it kind of uniquely identify this command, right? It's not going to enable us to know. Usually, these keys will have information on where from which device it came from, and basically the reason why we do that is, let's say for example you sent a command, okay? You sent a command with the mobile app. You lost you send the command for the mobile app. We already store that command, right? You say for example lock front door, right? And let's say you say lock front door. Let's say it was already sent, but you lost connection, right? And you press again. So we already received your lock front door. You press again. And if we see the same key, we are not going to store that command again, right? Because it will be locking the front door twice. So what we're going to do, if you're going to check the command, is that key already, do we have a command that is already stored for this device that has this key? If yes, we're going to return the existing command that is in the database instead of trying to store a new command. Because if you do that, let's say imagine you just let it through, and somebody keep on sending lock front door. When the device gateway is going to read this several lock front door, right? It's going to this several lock front door is going to try to lock the door several times, right? We don't want that. We just want to lock the door one time. Okay. So this idempotency key help us prevent those type of scenario. Okay. I hope that makes sense. Okay. Submit command use case. So we have so we went through the use cases, okay, and then we have our services here, right? Like in the interface, we have the clock. We saw that basically just simply return the current time, and then we have our fingerprint service or request fingerprint service. So we use this to basically create a fingerprint, like a uniquely identified string that is based on device ID, the command type, and the payload, right? So that allows us to know for this request, this is what was sent. Okay, this is what was sent. Right. So if you try to resend the same request with the same idempotency key, we know that there's an issue and we're not going to process that. Okay. So that's what that fingerprint is there for. Okay. Then we have our repositories, right? Basically to interact with our data store. So we have our device repository to interact with the storage for the device. We have get by ID, we return a device with a given ID, get by external device ID, right? This ID is our internal ID. External device ID might be the MAC address, right? Now we just check if a device with an external device ID is in the system, okay? And then we have this is where we add the device, okay? Then we have the iDevice command repository. We have get by ID, get by idempotency key, right? So we retrieve a command. Here we retrieve a command that has a given ID. Here we retrieve a command that has a for a given device, right? And using this idempotency key. So we check if there's a command that was sent to this device with this key. Okay. Here we get the commands, because we get the commands that was sent to a device page by page. That's what this does. And this is where we add a command, right? We add a command to a device. So if you look at the device command here, you see you have the device ID, the command type, the payload, the status, the idempotency key, the request fingerprint, and the device, right? Where we sending the command to. Okay. So that's that. So for example, usually, I mean, in most of the solutions that we are going to build together, if you want to kind of know the use cases, right? At least the way I implement clean architecture, for me, you're going to go to device or application. You're going to look in the interfaces and you're going to go to use cases, right? And then you're going to see what are the use cases, right? The use cases that the application here is supposed to handle. This is in the most of the solution that I'm going to implement, that we're going to work on. If you want to know quickly, you just go interfaces, application interfaces, use cases, and you will see all the use cases that the application support, right? And then of course you will see the implementation here. Okay. And then here we have errors, right? We have application exception, okay, basically implementing exception, validation exception. Again, here we are implementing our custom application exception, okay? Where we have our data transfer object. Our data transfer object are the objects that we use to send back to the outside world, because we don't want to send our entire entity model that we're using internally, right? So like I don't want to send, for example, in the device DTO, I have the ID, the external device ID, the name, the device type created at UTC. But if I pull the device here, you will see, for example, that in the device DTO, I don't expose the comments, right? The outside world does not need to know about the comments that were sent to this device. When I send information about this device, I don't need to send information about the comments. So you see that the device DTO does not have that. Okay. What else? Yes, you see, for example, I don't send, let's say I do a soft delete. I don't need to, the external world doesn't need to know, for example, if I do a get, if I try to do a get on a deleted device, I should not get anything. But for the sake of argument, my point is the DTOs, the data transfer object, are things that we want the outside world, like external APIs, external client apps, to see. And we don't expose everything. We just send the minimum that the client needs in order to do their work, right? That's why we have the data transfer objects. Okay. All right. So then we have our commands, right? We saw them before. These are the commands that we send in order to for use cases, right? So we have the register device command that will be used by the register device use case. We have the submit device command that will be used by the submit device command use case. Okay. So I think that's kind of the application layer. And then you have our domain layer, okay? Right, we have the device, right? We saw that before. It implements the entity class, and then it implements the interface iSort deletable, right? We have the device command, okay? We implement the entity, okay? So this is kind of what we have, okay? Then we have the infrastructure. In the infrastructure, we haven't yet implemented anything, and this is what we are going to be working on, okay? And then we have our unit tests. Unit tests also are empty. We are going to be working on those, okay? So for today, I think this is good, but I know you guys are dying to see me code, so we are going to do that, okay? Um, let's see. So one of the things that was missing, was on the infrastructure. No, it was on the application. On the application layer, if you look in the use cases, we have. Let me close all of this. Okay, close all tabs. Okay, we have the iGetCommand use case. We have implemented the getCommand use case, right? So we have it takes our iDevice command repository. We have a validator, right? A command query validator. Okay. Then okay, validation. Okay. So you see that we have the get command use case. We have a constructor. So we pass a repository, we pass our validator, right? So our repository validator, we have execute async, we pass the command ID, we call command query validator to validate this GUID, right? And then we call the repository, right? And say command repository get by ID is supposed to return us the command. And again, we're using this interface. There's no implementation yet, right? The implementation will be defined here in device on infrastructure. And then it will return us a device command, right? And then we have to map this into our DTO. So because that's what we are returning to the external world, right? We're not returning the device command itself, right? For the reasons that I mentioned before. And again, for those of you that know, you can use AutoMapper and things like that to do mapping. Right now, I decided to just keep things simple. I have a static class called here device command mapper. So all it does is we have a to DTO function, right? It takes the device command, right? And then it converts it to the device command DTO. Okay. So we check the device command is not null, and then we basically instantiate the device command DTO, and then we return it. And then we have another to DTO, we have overloaded this name, which takes the page results for like a list of comments from a page, right? This is for the collection. And then basically we loop to the items on that page, right? We check if it's not null. We loop to the item on that page and we convert each of those device command to device command DTO. If the conversion is successful, we add it to our list. And basically we send back the page result as a page result of device command DTO. Okay. So this is kind of how we're handling the mapping. So you see that we have a device command mapper and we have a device mapper. Okay. So, okay. So that's the get command use case, right? For example. And then you have the get device command use case, right? We have the iDevice command repository. We have our validator, right? And by the way, the validator are here. For example, the get command query validator is here. So it has the validate method. And you see the get command, the validators implement iValidator. Let's look at it. If you look at the interface validation, so you see that the iValidator, right? It takes what you call it? It's a generic, right? It takes we have the validate function, right? That validates any object of this type, right? Of this type. That's what this validate function does, right? So everybody that implement this interface needs to have a concrete implementation of this validate function. Okay. So here the get command query validator, implement the validator, and the type of object that it validates in this case is a GUID. So in this case, we check if the GUID is not empty. We say the command, if it is, the command we throw a validation exception. The command ID cannot be an empty GUID. Okay. So so that's that. And then we have the get device command use case. This is the use case where we retrieve devices that are retrieve commands that are sent to a device and retrieve them page by page, as I mentioned, for performance reasons. Okay. And here we have the repository, the iDevice command repository that we use, right? And then we have our validator, right? That takes our get device command query. Basically, we're going to check that the query that is passed is valid, right? So we have our constructor, right? We instantiate the repository and the validator, and then we have this execute async function. It takes the query, right? Then we come here, we try to validate the query. So you have for those of you that are wondering how are these going to be instantiated, these are all interfaces, right? In the following videos, you will see, of course, we're going to use dependency injection, and you will see how we set this up, right? And basically at runtime, it will know which concrete implementation to call, but just so that we go ahead. So for example, at runtime, this iDevice command repository will call the device command repository, right? Basically to get instantiated. This iValidator get device commands query will call the get device commands query validator when it runs. So if you look, we have the validate function here. It takes get device commands query. So we check if the device ID is empty, we say that we cannot query if we don't have a device ID, right? If the page for which we wanted the comments is less or equal than 0, that's not going to work. The page needs to be 1 or above. Okay. If we're not allowing the page size to be more than 100, right? Because we don't want people to say a page, to have page of million and stuff like that. So then it defeats the purpose. So we're capping the number of items that you can have per page. Okay. I hope it makes sense. All right. So this is to kind of give you an idea. Okay. So now we are going to work on the submit command use case. Okay. So we're going to work on the submit command use case. Okay. We're going to work on the submit command use case. So I'm going to add a new class here. And by the way, I think a lot of you, I know a lot of you use Cloud Code, use GitHub Copilot, but I think sincerely, I think that you should do this type of problems without any use of AI. This is especially if you are sorry, if you are a novice, right, or if you are new, mid-level, or anything, mid-level or junior, right? But you don't have to build in order to understand this concept, right? You don't, and this is one of the things that I wanted to solve, because I know we don't have, a lot of us are either entrepreneurs or have our own companies or working, right? And we don't have time to build an entire application to put all of these concepts together. So the goal is to find small problems, right? And go through those small problems regularly, right? Every day, every week. Take 2 to 3 days out of the week, 2 to 4 hours, right? To solve this problem, to go from requirements, architecture, implementation, testing, deployment, scalability, right? And then, of course, refining. But the goal is to do these exercises every week so that they become part of you. So, and the reason for that is how it makes you practice your hands-on coding, your solving, your architecture skills, your problem-solving skills, right, your algorithm skills, and also, so even when you're at work and you are using AI tools like Cloud Code, Cursor, GitHub Copilot, you still can write code, right? You still can read read code. Of course, in all organizations right now, you have to read a lot more code than you write, and you have to understand that. But you should still be able to reason and architect code. Is an architect system. This is actually the most important skill. And the only way you're going to be able to keep reasoning and not only depend on AI is by doing these problems, right? Like they were math problems that you are solving, but they're actually engineering problems, right? You are not doing lead code. You are not doing lead code here. Lead code has its place, right? It's useful. It's part of your training, but we are doing engineering problems, right? And you have, yeah, I strongly believe that this is what you need to do in order to keep your skills up and sharpen them every day. And you can use whatever language you want. The language is not the issue, right? But the engineering, the problem solving, that's what we are practicing here. Okay. All right. So we're going to create the submit command use case class. Okay. Right. So this class is going to implement this interface, right? So it implements this submit command use case. Man, I wish I could share. My screen is too big, otherwise I would have shared the whole thing. But I'm looking at my diagrams here. The reason why I love architecture and I love diagrams is that I can quickly see with my UML. If I forgot, I can quickly see what what I need, right? So for example, right, I see from the UML here that of course I'm going to have I'm going to need my device repository and the device command repository, right? So, okay. Repository. Okay, I'm going to also need my device command repository. Okay. Okay. And then we're going to need, are we going to need that now? No, for now, we're not going to need that. Okay. But we're going to need for sure, right now, we're going to need our request fingerprint service. Okay. And we're going to need a unit of work. Okay. Okay. And then we're going to need a clock for the time. Okay. And then we're going to have a constructor here. Okay. And we're going to pass all of this, right? And the reason why we do this is because this constructor is going to be used to help us during when we do dependency injection and things like that. Okay. So now we see that it's still throwing an error. This is because we haven't implemented the execute async method, right? I can come here, I can say show potential fixes, and I'm going to say implement interface. Okay. So you put the execute async method, right? So right now it throws a non-implemented exception because we haven't implemented anything yet. Okay, one thing that I like to do, I like to have a quick comment here. You don't comment just saying what the class is doing. So this class describing the use case pertaining to the submission of a command of a command uh of a command for of a command for of a command of a command that is supposed to act on act on a device, act on a smart device in the home. Okay. So class describing the use case pertaining to the submission of a command that is supposed to act on a smart device in the home. Okay. So 2 lines, That's enough. Okay. Now, we're going to need um we're going to need mm, we're going to need a validation for the submit device command. Okay. So here, okay, so in the interface, for validation, okay, so we're going to have a submit command use case validator, of course. Submit command use case validator. Okay, and okay, okay, so we're going to okay, and it's going to implement the I validator interface that we have, and it's going to take the submit command use case. Okay. And then we're going to implement the validate method. Submit command use case, sorry, submit command, sorry. It's not the use case, we're validating the submit command. Uh, okay, hold on. What is my command? Submit device command, sorry. Submit command use case. Okay. Uh, let's say submit, okay. Submit device command. Okay, so we need to, okay, there we go. We're going to paste the command here. Okay. Okay. Now, mm, okay. So we're going to have, okay. So we're going to look at how, let's look at what this command is expecting. So we have the device ID. We need the device ID. Um, we need the device ID. We need the idempotency key, right? Uh, yes. And the command type, yeah, the device ID and the idempotency key are needed. Okay. So we are going to have we're also going to have a list of string where we keep uh errors. Okay. Uh, now we are going to check if the command is not, we're going to throw an exception. Okay. Um uh uh hold on, new validation. Okay, in the domain. Okay. Okay, 1 second. We have a validation. Yep. Yep. Okay. The validation exception. Okay. So, oh no. Oops. No, that's a mistake. I want device application error. Okay. Now the validation exception. And here we're going to say that the command cannot be null, right? Command is required. Okay. So if the command is equal to null, we throw this exception. Okay. Now, we have to check also. We have to make sure that the device ID is not empty. Yeah. We throw a validation exception. The device ID cannot be empty. Device ID cannot be empty. Okay. And then we need also, actually, we're not going to need, I don't think we're going to need this. Hold on, let me. No. Okay. So now, what size is okay? Now we're going to say, if command, so if the add dependency key is null or empty, we're going to say that we require that. Okay. Okay. Exception. Okay. This key is required. Okay. So when at runtime, when we use dependency injection, that's the validator that will be used. Okay. So okay, so we have a submit command use case here. Okay. We have a submit command use case here. Okay. Okay, so now let me see, because I'm looking at my diagram here, my flow. Okay. Okay. We need a validator. Validator submit command, submit device command. Okay. Okay. So we're gonna pass. Let's see. Our validator. Submit device command. Okay. So validator. Okay. So now we're going to check. Okay. Sorry. Execute. Go to definition. So this can be null. Okay. So we have added a validator, right, as one of the in order to validate the input that comes in, the command that comes in, right? So, and here we are making sure that the executor async, because when we submit the command, we can have it can be null, right? Something can happen, right? So we are going to have a device command DTO, DTO. Okay. Okay. So we check that the command and inputs are valid. That's the first thing that we do. So we call the validator. So if there is any error on the command, it would throw an exception like we did. Okay. Now we are going to try to get the device. Okay. Okay. A device receiving command. So okay. So I'm putting this comment so that these comments so that you can follow the logic. So the first thing is retrieve the device that is not receiving this comment, that is going to be receiving the comment, right? So we're going to do that. We're going to use the device repository, and the reason why we have returning comment DTO is because we haven't used the wait yet. So we're going to get the device. Okay, so let's say wait device repository get by ID async, and then we are going to okay. What's the problem? Okay, it's because of that. That capacity. Sorry. It's not device. Sorry, it's device. Okay. Okay. So we have the device. Okay. So if the device is null, we know that there is an error. We have to throw an exception. Okay. Okay. So we throw an application or exception. Okay. Um. mm, we can say, okay, the device with ID. Mm, mm, device with ID, commander device ID does not exist. Okay. Mm, okay. Mm, so now, so if so we check we receive a command, right? So we check that the device for which we receive that command is in the system. Now we have to make sure that the type of command that is being issued for that device actually match the device. So let's say, for example, in the command that is being sent, the device is a door, but I'm getting the command to set the temperature. The command is set the temperature. We should not allow that, right? Because this is a door, we cannot set the temperature on the door. So, this, if we come to this, that means if we come at this point, that means the device exists. So there's we have a method called can accept, right? And it takes the command type, right? So we pass the command type. So if for some reason, if the command type that is passed is invalid, we have to throw an application exception saying that the command that is sent for this device is invalid. Okay. Okay. The command. Okay. and type be sent cannot be sent to a device to a device to a device of type was the device type. Okay, so that's the so if the device if you're sending a command that is not appropriate for device, we throw this exception. Okay, now we have to check if this idempotency if the key the idempotency key was used before. Okay, uh if not, we're just going to return that command, right? So we're going to try to retrieve I'm sorry, we're going to try to retrieve get pay get by idempotency key async. So we're going to try to retrieve the command by the idempotency key. Okay. Okay. So command, okay. Sorry. Oh, okay. Let's say run command. Okay. Okay. Let's say can submit command, submit device command. Okay. Okay. So, so this is if we try to see if this command uh, was already sent, right? If we already have a command with this potency key and this device ID in the system, right? If not, we are going to store it. Okay. So if is equal to null, okay. Uh, so okay. No, sorry. Let's say, sorry. Let's say it's not equal to null. Okay. So we have the command, right? We have the command with the idempotency key. Now we have to check if we have to make sure that the fingerprint of the command is the same. Because if it's not the same, that means that we are trying to send a command with the same idempotency key, but with another request, right? And that we should not allow this. Okay. Okay. Mm, yes. So now, if the okay, okay. So if the current submit device command is not equal to null, and current submit device command uh the request fingerprint, right, uh is not equal to the command um mm, ah because we need to compute the fingerprint. Okay. So uh okay. Retrieve the device or the command. Okay. So now if we have this command, okay, so if you are this check, we have to compute the request fingerprint. So to compute the request fingerprint, we're going to check, we're going to use the request fingerprint service, right? Okay. We're going to create, and then we're going to pass the device ID, comment type. Again, that request fingerprint service is going to be implemented in the infrastructure, okay? And that will be in the next video, okay? So stay tuned. Command dot payload, okay? Sorry, what is that? What's the problem? Ah, it is because in the we made a mistake. It's not command type. Has to be from here. Okay. Okay. So we compute the request fingerprint. Okay. So we attempt to retrieve the attempt to retrieve attempt to retrieve to the command. Right. Then it's the key. If there is a command, if the idempotency key, but the fingerprint is not the same. So if we have a command that has its idempotency key, but the request fingerprint is not the same, there is a problem. It's an issue because because it should be the same because if it's not the same, because idempotency key tells us that the command has already been used, and if you're sending me that same command, right? But the fingerprint of the request, or the parameters that you are sending is different, it cannot work, right? So I want to throw an exception telling you that the this command has already been processed with a different set of parameters, right? If there's a command with the the fingerprint of the request that do not match what is in the data store, which show an exception. Okay. So we're going to throw an application exception. Okay. Sorry. Uh, okay. Sorry. Let's put it like that. Okay. The command. Okay. Okay. So we set up it's cleaner to do it this way, and because when you're concatenating a string, you are using more memory because strings are immutable, so it recreates them all every single time you do that. Okay, so we're going to be pros here, and okay. Okay, okay, okay. The comment cannot be sent. Okay, comment. Okay. So the idempotency key. So we're gonna throw idempotency key. Um, idempotency key. Mm, so this other policy key has already been used for a different request. Uh, different request. Okay. Right. Okay. So now, if the current submit device command is not equal to null, and the current submit device command, the request fingerprint is equal to request fingerprint, we simply return, we have a mapper. Yes, do we have a mapper? Yes. So we're going to return, we're going to return to DTO. We're going to return this. Sorry. Okay. Well, yeah. Uh, uh, okay. Command DTO. Okay. So, okay. So if it's the same idempotency key, the same request, we simply return that command, right? Here we have the here we have the same command, same request. We simply return this one. Scan it. Okay. Oh, uh, what? Why? Okay. So then here, otherwise, in this case, we are going to create. So this is the case if the command is null, right? So here we are going to create it. Okay. Okay. We are going to create it. Okay. So we device command. Okay. We're going to create it. Okay. So we're going to create a command. Okay. The importance key. Okay. Okay. So sorry. Uh, command. Okay. 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 Then we're going to send oh sorry. Uh command payload, importance key, the fingerprint. Sorry. We have a request fingerprint here. And then we have a clock. Okay. So we have that. Okay. And then we have to, so this only instantiate, this is I mean, this is kind of a factory pattern. So we instantiating a device command, right? And then we're going to send a command, we're going to use a command repository, right? And we're going to add the cancellation token. Okay. Okay. Now that we have added that, oh, sorry, command GTO. Okay. So if there's an error, it will throw, if this, oh, sorry. So we added that we need the unit of work to save this, save changes async. Okay. So we're saving, so we add the command to the repository, and then uh, we're saving the changes. Okay. And then we put the map to DTO. Okay. So let's, okay. So this is what we have. Okay. So you see this simple submission. Okay. So now here we have the same command. So I can simply return it. Okay. Here is a command. We have validated that it is and belonging to the device. Positive to device of this type. We simply store it. Store it. Okay. So let's recap. Now, we have a submit command use case. So it's a class that describes a use case pertaining to submission of a command that is supposed to act on a smart device in the home. Okay. So you see that we have our device repository. We have a device command repository. We have our request fingerprint serviced. We have a unit of work. We have a clock, and we have a validator. And you saw that we implemented the validation. Where was it? Yes, we implemented a submit command use case validator, right? So this is what will be instantiated, when we do dependency injection and all of these things. So we have a constructor. We pass the different parameters, right? In our constructor. And then we implement the execute async method. So the first thing is that we make sure that the command is valid. Okay. If it wasn't valid, it will throw an exception here. Now we get the device on which we are sending the command. Okay. If the device does not exist, we get it by ID. If the device does not exist, right? We throw an exception, an application exception. Now we check that the command that is being sent can be accepted by that device. Okay. Like the lock or the thermostat, or the security panel, right? So, or the light. So we basically, okay, if it cannot accept, if for whatever reason the command that was sent cannot be accepted by this device, we throw an application exception saying that the command cannot be sent to a device of that type. Okay. Now we compute the request fingerprint, right? Basically, the request fingerprint allows us to know which parameters were sent for that request, right? It's a uniquely identify the request. Okay. So now we try to retrieve the command by using the idempotency key to try to see if that command was already sent. Okay. So if there's a command with the idempotency key, but the fingerprint, meaning the parameters that were sent, are not the same, we throw an exception, because that means that this command was already sent, but you are trying to send the same command with different parameters. So I'm not going to process it. Okay. So the idempotency key, so we train the communication, so the idempotency key has already been used for different requests. Okay. Now, and then so we throw an error. So now if the command exists, and the fingerprints are the same, I just return you the command. That's it. Okay. Now, if there's no command with that idempotency key, that means it's a new command, right? We have already validated that the device exists. We have already validated that the command type is valid, right? So we basically now create using like kind of a factory pattern, create an instance of the device command, right? Using the create method on the device command class, right, as a static method. We pass the command information like the command type, the device ID, the payload, the dependency key, and the request fingerprint that we computed, and the current time, right? And we add it to a command repository, and we save our unit of work, and then we simply map our command entity or command entity to a command DTO, and then we return it. And of course, so that's the logic. Of course, we have to write unit tests for that. But this video has been, I think, long enough, and in the next video, we will work on the unit test, and we will work on the implementation of the repositories, the device repository, the device command repository, and the request fingerprint service implementation. I hope this was helpful. I hope you had a great time. I had a good time. I'll wait for your feedback, and I hope it was helpful. And again, if you need the diagrams, the documentation, let me know in the comments, and I will send them to you. All right. Have a nice one. Peace, guys. Bye-bye.